How do you guys feel about playing some Go Fish?
Sounds fair.
So you know, I'm not the best at shuffling. My parents never really taught me. Get a little nervous around people when I shuffle too, so.
Wow, that was bad.
Yeah.
Maybe I should deal.
Okay. I think those are mixed up enough. We'll have to see. I'll just give those to you.
I don't have hands, but I can try.
Do you or a loved one struggle with shuffling or dealing cards? Well, do we have the product for you?
It's Shuffler Steve! Hey guys, I'm Katie and this is Shuffler Steve. I'm going to give you a broad level overview about his functionalities. So what Shuffler Steve does is he accepts the number of players and the number of cards to be dealt. Then he will rotate around on his base via stepper motor, find the players, and then deal a card to every single one.
So this is our user interface. You can adjust the number of players by increasing or decreasing. You can also select the number of players by selecting the button on the IR remote. Pressing play goes to the next page. Pressing back goes to the previous page. You can also press forward to go to the next page. Has the same functionality where you can select the number of cards by pressing a number or increasing or decreasing. Pressing play takes you to the menu to start, and then pressing again starts the process of shuffling and dealing the deck.
Hi, I'm Spencer. This is the LCD I2C adapter. What we did was we took the 16 digital pins from the LCD that go to 6 output pins or control pins on the Arduino. And by using the I2C adapter, it allows us to take those 6 pins and only go to 2 pins on our Arduino, which is the SCL and SDA pins. We did this because it allowed us to control all of our code on one Arduino and minimize the amount of wiring that had to be done.
All right, for the shuffling functionality, what you're going to do is place your cards in either one of Steve's arms. There are 2 DC motors down here connected to their own individual power sources, and they're going to alternate sequences so that you get the best shuffle, and then they're going to dispense down here in Steve's mouth, ready for dealing.
Hello, I'm Evan, and I'm going to talk about our card dealing mechanism. If we look into Steve's mouth, we'll see that there's a DC motor, and attached to its shaft we have a 3D printed wheel and a hot glued zip tie that we are using to fling out a single card at a time. The DC motor does not reposition, so it will spin continuously, and in order to spin 1 revolution we use a quadrature encoder, which has 2 channels, an A and a B, which are 90 degrees out of position. And by counting the leading edge of B, we're able to determine how much the DC motor needs to spin to create 1 revolution.
Hi, I'm Michaela, and this is the ultrasonic sensor, which works in conjunction with the stepper motor underneath the base. The ultrasonic sensor sends out a ping to find the distance between it and an object, and when that falls within an acceptable range, it will mark that position, that degree, as a player. When it gets to the last marker, it will mark that as the last person, and then the first person it will deal to, and then it deals in conjunction with all of the positions that it found before that.
So I'm going to talk about how our stepper motor interfaces with the base. So we use a stepper with 200 steps, and in order to make sure our device rotates in 360 degrees without any wire entanglement, we've oriented the stepper upside down. So we've connected the stepper to a Lazy Susan base, which we've printed a 3D printed adapter that connects with the stepper gear on the shaft. And one of the problems we found was that there was a lot of weight on the stepper motor, and so using this ball bearing ring removes some of that load from the stepper to allow it to rotate more easily. And then the other problem we found was that there was a heat problem when we had continuous power through the microcontroller that drives the stepper motor, and so there's a switch that we're able to interface with, so when it's idling we can turn it on and off.
Alright, so this is our LED strip. We used a WS2811B light strip. It has 3 inputs: power, ground, and a digital pin. It is being run on a separate Arduino and separate battery.
don't know.